We are beginning again. Our next is packaging with Dave and Taylor. Please give them a round of applause.
Hey, just quick intros. I think most of you know me at this point. I'm Taylor Thomas. I work at Cosmonic. I do a lot of Watson Cloud and the PMCF space. I've been involved in WebAssembly for a while. And
I'm Danny Macovei. I'm at Jaff Labs, helping over there. We've been involved in registries and now SIG packaging close to 2 years.
Yeah. So I think the best thing to do here to start off with is let Danny give you an overview of SIG. Danny's been around probably doing a lot of this even longer than I have with the SIG packaging and SIG registry. So give you a quick overview of that. Then we're going to dive into what's been going on since the last Plumbers Summit. Show you some stuff live. I don't have slides. I'm going to show it live, and then we're going to talk about some of the future from there. So, Danny, that.
Yeah. So basically, we've recently kind of moved our priorities. We were SIG packaging, SIG registries, and that was a lot of research into like protocols and stuff. And now we've been focused more on distribution and integrating our tools in various tool chains and stuff. A lot of the work that's like kind of been happening over the past 6 months has been repo called some package tools with like a library and a CLI called Wackage. Taylor's been doing a whole bunch of work there, and that's kind of been stuff. I think he'll kind of talk about that, and then I'll talk about some of the stuff that's like more in a prototypical phase. But yeah, so Taylor.
Yeah, so in the beginning, I have to back up a little bit to give some history here. So it is almost right after the last Plumbers Summit, like a week or two later. We finally got together as well with a lot of people in the CNCF WASM working group. And then James, big shout out to James, who's here. And then another person who doesn't normally come to Bytecode Alliance, Brandon Mitchell, who's from the OCI side. We got together and kind of gathered the community together and worked on to represent these things in OCI. Now, the reason is, I think all of us eventually down the line want smarter registries than things like NPM, right? And all that kind of stuff. And like, there's cool things we can do with components. But right now, the thing that people expect, the standard that's kind of around is OCI. So we decided we wanted to put this all together. We had lots of contributors, multiple people from Bytecode Alliance. Luke was there on several of them. Those were some good conversations. And we created a kind of standard format. So for those who aren't familiar with OCI, OCI was obviously, from its name, Open Container Initiative. It was meant for containers, but it's kind of turned into an all-purpose artifact registry. A lot of things are there. And there's an actual OCI artifact guidance and standard around how this works. So what we've done is said, okay, well, within that artifact standard, how could we represent WebAssembly in either of its formats? And so that is what we did here. So this is all available. I can share this in Zulip afterwards. This is at the tag runtime deliverables for it, which is where the WASM working group's at. And what it does is defines this standardized format. A container, OCI container, like the Open Container Initiative stuff has two things that are always in it. There's a config, and then there's the actual data. And the manifest is pretty simple, and essentially it allows us to support layers. Right now, we only support a single layer. So you have your final compiled WebAssembly binary that's in there, often a component. In the future, we've left it open to be able to support what I've always called the exploded view of a component. So if you have like 10 components composed together, you could explode them out into their individual parts so that you have less storage requirements because you have those things as a separate layer. Those are all just in the weeds details. But what really matters is this config format you see up here. And this lets us identify all the different exports and imports, as well as an optional target for what a component could be targeting worldwide, as well as, actually, that's really just it. There's all the other standard metadata that's there. So essentially, this has all the things that we started doing. So this is way back. We worked from about February until end of April to get this all solidified, and then we started implementing it. And right around the same time is when the SIG packaging stuff came. So what we came up with is Watson package tools. There's the previous existing project of work that's still supported in here underneath the hood, and then OCI as well. And so Watson package tools is a layer over the top of that does all the handling. And like Danny said, it has a command line tool called package that I'll be showing off. But the whole purpose of what's going on right now is trying to make packaging, and at first here, just the very first step is just making packaging interfaces pretty standard. So I define, WASI HTTP. I have that available as a WIT package, the binary format, stored in an OCI registry somewhere that I can pull down and consume. The same thing can be also for like final compiled relatively well. And so this tool chain lets you basically manage all of that. And the goal is for it to be a standard. There's two kind of integration levels. Everything, if it's in Rust, it can be integrated. But the Go people who heard me say this know about this already. Is there's essentially a standard config file that we're hoping that everyone can centralize around, because we know there's some. Go is the perfect example because Go likes everything in Go, and so that's perfectly fine. But as long as they can read the same config file and use the same thing, that means the tools are portable across it. That means the same config that I'm using to build my Rust project, I can go use to build a Go project is the goal, or a C# project, or whatever. And so this is the config format, which I can dig into, and I'm actually working on extending a little bit based on some feedback from Ralph, literally right now. But I'll talk a little bit more about this later. I didn't want to take too much time going over this. We can talk more in the future. And this is basically the integration point. And there's one more I'll show in just a second. So this is the bare minimum integration point, but then other tools can take that are using the Rest toolchain can use this as well, or can use the CLI called Wagner. So what we're doing here is, what we're going to do here is actually show you what that looks like. Okay, so let me embiggen for crowd. Okay, so is that good, Grandma Bailey? Okay. Sorry, that's a joke we had. She always says like, no, I need it bigger. And so, so that's hopefully big enough for everybody. So what I'm going to show here is what this looks like. So I'm going to go ahead, and this is actually inside of the Wackage repository right now. So this literally just merged to main like 15 minutes ago. So it is fresh, hot off the press, and you can try it yourself if you want to. Just have to go down and compile. But I'm going to go ahead and change directories into Wackage core, where I have these test fixtures around. Okay, actually, I'll just do that. So right here, I'm going to show you. So we still expect that WIT directory. That WIT directory is kind of the standard right now. As things evolve, we can continue to support more. But what happened right now was before you had to use a tool like WIT-deps, or you had to manually copy paste things around, or you had to wait for something like Cargo Component to support all these kind of things, and that was just for Rust. And you just basically had to wait for each language to go along. Now we still want that. Cargo Component already has support for all of this stuff that I'm showing already built into it. If you're using that, C#, thanks to James, has a bunch of stuff to use this already as well too. But what this allows you to do is now fetch these dependencies. So normally you would have some sort of depth. I'm sorry, I should ls this first. Let me just tree it. So normally you'd have like WIT and then a deps directory. In this case, I just have my world. So if I look at my world, you can see here, I'm just doing like a test like plugin that's using like a CLI, and you can see this is a little bit more complex. It has includes and imports and exports. And the thing is that can basically act as your dependency file for the interfaces, not for other things you want to compose with it. And what we just finished adding in is you can do, this is obviously built for my main, is I have a WIT subcommand. I'll actually show it off. So WIT has a couple different things, and I'll show all of them off. But with this WIT command, we'll let you fetch the update. So what will happen is this will go through, and it will, now if I do tree, you'll see that I now have the package that was pulled from the WASI, the main WASI interfaces in GHCR. This was using the OCI spec that I was just showing under the hood and pulling it all automatically. And it can always fetch these things from them. You'll also see that it generated a lock file. That's the other standard piece of this stack that we would expect anyone to be able to integrate in with. It's a standard lock file format, because the dependencies are going to look the same no matter what language you're pulling in. So, I mean, if we look at that, it looks exactly like you'd expect that. There's just like descriptions and SHAs and where they got pulled from and whatnot. That's the magic. That's how it works. So you can also output this in binary WIT format as well. So you don't have to output it in textual format, but each of these is available. And now, if I do our favorite thing, watching Rust build, this will actually be really quick. So you'll see that we'll be able to build. There won't be any warnings or error, or there'll be warnings because I need to update one of the targets. But you'll see that it built, and I can actually just run that. So if I do, gosh, I couldn't remember Wasmtime serve target. Okay. Oh, I didn't compose. I actually had a trick for this. Normally I use my, I'm not going to do it right now. Trust me, it runs. I'm not going to worry about fixing that right now. This is the test fixture, so I don't have that in there. I just want to make sure it builds. But anyway, once you have it, you're able to take it and build it just like you would any other component. Now this also works before. This is actually adapted from the WIT command that was or the WIT binary that was part of cargo component. It didn't really belong in cargo component because it had nothing to do with cargo component. It was something that anybody could use. So that is also now in here. So if I go to, like, I just copied WASI HTTP into here. So this is just the WASI HTTP from the repo. And now you're able to take these interfaces you define and package them up. So you'll notice that here, once again, way lighter. So it's there. It's way lighter than it used to be. It just has the width defined. There's no depths embedded in there. But then what I can do is say, okay, I'm going to do width build. And then that just built the whole thing, fetched all the dependencies, and then wrote the package out. And so now if I do Wasm tools and then print out the width, it's just going to have the world here, but it does have all the other dependencies embedded in here as well. So you'll see that it's now packaged up, ready to go, and I can pull down that dependency. And so that's what's being used with all these things. The idea was making this basically so drop dead simple that, like, as long as any language hooks into either the CLI or the tooling or whatever, it can just pull it, and people don't have to think about those underlying interface dependencies. Now the Whackage tool also has, I have it in my path from the current main. You'll see that we have Whackage get and Whackage publish. This lets you publish and get using that same config file. So you take that image that I just built with, like, the WIT build, and be able to push that somewhere. There's also a helper one underneath for OCI, and this is just for raw OCI. It can push things to any OCI reference. So that could be a runnable thing, or it could be a WIT package like I just built up. This can be used inside of CI pipelines and all that once you've built your component and want to push it up to a registry. So that's essentially the kind of like path where we've been here. What we're finishing up is we're, like I said, integrating some of the config changes so it's easier to specify. There's kind of a weird hop that has to do with a well-known file right now. We're trying to remove that if you don't need it, and trying to clean some of that up and make this usable. So essentially, we're at the phase where people can start using this. Everything we've been doing for the past 2 or 3 months has just been going to this, get MVP feature complete. So what we're very close to that. Like I said, I'm just working on the last things. It should be honestly done by the end of the week with a new version cut. That doesn't mean it's done. That doesn't mean we're not going to keep evolving. It just means we're in a spot when everyone can start using it and integrating it into their tool chains. So that's kind of like where we've been, like what things are going on. Before we move on to kind of some of the future timeline stuff here, what questions do people have? Any thoughts, concerns, worries? Yes.
When you run, I think it's a few lines up, what you just ran.
The build?
Something build?
Yeah. That one.
What does it actually build?
So what it's doing is it's going and fetching each of the dependencies of the WIT. So the kind of logic if I show you. So we go into here. So like this is the proxy world, right? So it's going to go into here and it's going to say, okay, I have all of these different dependencies that are listed inside of my worlds. Here's the different things, and here's all of the sub dependencies I know about. It's gonna use basically the underlying WIT parser stuff, which is what's going on. For later discussion, I have thoughts on how we can improve that API. But it'll read all these and I'll say, oh, look, I need to pull WASI clocks. I need to pull WASI CLI. I need to pull like whatever it's going to need for its dependencies. The config file maps each of these namespaces. So WASI is mapped to wasi.dev. And that has a well-known file that redirects your client to ghcr.io/webassembly, and then has all of the WASI interfaces inside of there. And it pulls those down, and then it adds it all into the final resolve, which is the like saying all my types are resolved, everything's good to go. And then it uses the component tooling with component, I believe is the crate, to package that into a final binary format, which is called, there's two different ways you can decode WASM. It can either be a component or a WIT package, and it is a WIT package. More confused?
So yeah. So the output WASM file is not.
No, it's not runnable. It uses it so I can do, like I was showing before, the WIT, or actually, let me just do print. So like you're just seeing here just the imports. You're not going to see any other logic that's in here. It's just showing like all the gluing together of the stuff. But like I can start to look for, like if I look for CLI, I'm going to start finding all the CLI imports in there. So it's just a binary representation. The binary representation is really nice because like in the future, right now we write out each separate binary, but we could technically take everything of somebody's dependencies, compile it into a single binary, and then just have like, that's my dependency binary with the interfaces. There's a whole bunch of other cool things we've talked about in the future, but you're building something that is not runnable. It's just an expression because we're taking advantage of the fact that components are self-describing. So we're packaging it up as something self-describing that something else can consume, because you can theoretically take someone else's component and then use that as a basis for your interfaces if you want to as well. Not that that's always recommended, but you can. Yeah. Yes.
Does package build? Yeah, does it also support a newish support for bundle line packages in a single file?
It does some of them. Honestly, like I'm using the latest tooling. I'm pulling and I'm iterating over all dependencies when I fetch these things. When I'm printing some of the things, I'm not using the like nested, so nothing's being printed out nested. But I think I do extract all the depths properly. I did try to test this with a couple different things. So
I mean the other way around. Emitting the WASM file. The key reason why we introduced support for line packages was so that a binary WASM file isn't the only way to bundle multiple packages. So I'm asking about output.
oh, output, yeah. Right now, I do not output the WIT as like inline packages. I can look into doing that. Like it's just I'd have to refactor, but right now I'm just outputting it. Just because right now everything's in its own depths, in its own directory inside of depths, or is what a lot of things currently use. And so just having that there as a standard, adding that in, completely open to do. Just doing it quickly.
Pretty sure that if you've got like a depths folder with a bunch of packages in it, if you round trip, you just like turn it into binary. Sorry. Yeah, I think that if you have a bunch of WIT packages in a bunch of subfolders, that actually if you like turn that whole thing into binary and then print it back out again,
Then you get that, yeah.
So yeah.
Other questions? Yes.
I would love to talk about what you think could be improved here, especially in terms of like depths, the tooling of like the WIT parser crate. Just want to put that out there. We'd love to chat.
No, I knew this would be the right forum for that, so I was definitely saving it for the birds of a feather stuff in these days, because I've now used the resolves enough that I know where I'm like, hey, that's really great. And the other times I want to like go bash my head against a wall. So like that's typical when the phase of development we're at in this. So I want to talk about those things out, and then probably just submit some stuff upstream. Yeah, go.
Taylor, you already know, like, asked this question before, but even package and WASM tools, they have a subcommand now called WIT, package to WIT, and WASM tools component WIT. So what are the key considerations that led to maintaining like two separate tools instead of integrating them into like one tool?
Yeah. So right now, this is another discussion item I want to have in the birds of a feather with people who know about, especially in charge of WASM tools things. The reason why this was done separately is because WASM tools is meant to be pretty much like everything's local, everything's there. It's not registry aware. all the whackage tooling is registry aware. You're going to make network calls. You're going to have like cached files. You're going to have all that stuff that you would normally have. And there's good arguments on both sides. I love that, like for languages that are depending on CLI, having it all in one makes a lot of sense. But also like WASM tools is already a pain to navigate through and figure out which thing does what and which magical incantations you have to do with each tool or combination of tools to get what you need. And so that's the disadvantage. Now we're going to add more, and some of them call out to your network. You know, like there's arguments to be made on both sides. So I'm all for trying to see if we can combine these or figure out the better way of doing it. I will say I've given a lot of talks of showing like composition in action, and the number one point of feedback I do get from everybody is like, that is so many tools. Unprompted, every single time. They're like, I absolutely loved what you just showed, but why are there so many tools? And so definitely a point of a conversation I really want to have, because I do want to make this as easy as possible coming in. I don't want it to be like simply and then have this list of 5 tools you have to download to get it to work. So like that's, and I mean, some of those things were like the adapter step that we're very close to not having to do in a lot of languages anymore. Like that was just technical and we're going to get over it. But other ones I think are organizational and we can fix. Questions? Anything else before we move on to what the future looks like? Okay, while Danny's starting to share, I'm going to, let me stop sharing. I'll just say like, so for short term, where we're heading right now is you've seen the stuff that just landed. We're going to cut a new release. We're going to add a config subcommand that helps managing the config, make that step a little bit easier. And then we'll also, is everyone else seeing that as like super tiny? So that's kind of those next steps as we're making that, and then addressing immediate feedback. The call to action here is go try this. Once again, just to make him blush, huge shout out to James. Like James has been doing this with the C# with Componentize.net. It's really, really, it's really cool to see it actually like happen in action. And I know there's a bunch of other people like, there's a bunch of other tools that have started to integrate this. You have, besides the Componentize.net, you have Spin has started to integrate these tools. Wasmtime has integrated these tools. There's a couple others listed that I don't remember that are on the adopters thing of like the OCI Wasm stuff. The Go people are starting to use some of these things. So like we just need people to try it and let us know what the rough edges are. That's really like, this is supposed to be the official like kind of tooling that everyone can centralize around, and we're trying to make it as friendly as possible. Please let us know there. But beyond that, there's more coming on, and that's where Danny's going to talk about some of this cooler stuff that he's, that kind of that future looking thing. We need to keep looking to the future while we're trying to keep the present going too. So want to kind of talk about that?
Yeah. So yeah, I think that when it comes to like composition and dependency resolution and fetching things out of a registry, a lot of the times the demos that we have are kind of like platform oriented. And
Zoom in.
sure. Oh,
Yes.
yep. Anyways, I'll explain this in a second here. But yeah, so things are kind of like platform oriented in a lot of the demos that people do, which makes sense. Are contributing to the component ecosystem, are building platforms and have users that they're trying to get to use platforms. And so I'm just like, as an example of platform kind of oriented dependency registry usage, talk about WAC for just a little bit as something to compare it to. So generally when people are making, they're targeting like import, export interfaces, and those interfaces are kind of what we generally are thinking of as dependencies. And you could have multiple implementations of the same interface. So if you're trying to do some CRUD kinds of things and update state, maybe you want to compose this component with something in one circumstance that's like local, and then in another circumstance it'll be SQL, and in another circumstance it'll be like reaching out over a network. And so having your dependencies be these WIT interfaces is really useful because you can take the same component, compose it with one thing in one situation, compose it with another thing in another situation, compose it with another thing in another situation. And that's kind of like what WAC does here. And so here we have WAC, which is a tool that Peter Hune made a while ago at this point. And basically for all of the interfaces that are in the world that you're targeting, you then would point to which implementation of that interface you actually want to use later. So when you first have your component, it's not runnable until a later time after you've done your composition, because you kind of want that like degree of freedom where maybe many different things could fill in that hole for you, and you want this flexibility that the component model gives you, which makes a lot of sense. So just here, like this local sorter thing has a dependence on an interface right here, and then we're saying which implementation of that interface we actually want. And WAC is actually registry aware, though it's not yet using WASM package tools, which Taylor was just showing off. One of the things that like we need to do soon is get WAC to use WASM package tools so that way it can leverage OCI, and that'll be really cool once we make that happen. But if you're not thinking about things in terms of a platform, and rather you're just a developer that heard that library, and maybe it's not doing this CRUD thing where the state might be on my machine or on another machine, and I might want to use HTTP or not. Maybe like somebody just made a useful regex parser in C, and that's the only one I ever want, and I just want to depend on that, and it should be as simple as cargo add or npm install, and I don't want to say which implementation of this interface that I have. So that's kind of the like space that what we are currently calling unlocked depths, but it's like still very much being bike shedded, is like trying to solve. And so as an example, we basically have, and this is like something that we've like shown off a little bit, and I'm actually going to zoom out a bit so we have a file system that we can look at too. So here's like some WAT that we used that like leverages this like unlocked depth syntax that like already exists and has existed for I think a year at this point, where you would specify a dependency on an actual component rather than like on a WIT package. This would be an implementation of an interface defined or a world defined in a WIT package. And we also have like some WAT for some other components, and we have like this like meet one here is specifying a dependence on the other implementations of components that we have. And then you would basically have, or currently this works only with the work CLI. This is also something that would need to get like ported to work inside of WASM package tools. But you have the ability to lock an unlocked component. So basically your unlocked component would have dependencies on a bunch of implementations, then SEMVer resolution would occur, at which point you would have locked dependencies with pinned versions and integrity SHAs for all of these. And that locking process is also going to look at what all of the interface imports are for each of the things that are being depended on and specify here which instantiations of each things are going to be done. And so this is like actually part of like the warg CLI like lock command right now. And then we also have this bundle command, which basically once you have all of those things, it can actually go ahead and inline the definition of those things because we don't have the actual logic contained in the locked component as it was just displayed. And so the bundle command would basically, or currently, is a way for looking at those specifications of a pinned version and integrity SHA and basically inlining the definition of that component so that the thing that you have is actually runnable. And so this actually is usable in, or you know, there are actually tools that already kind of make things this way. I wanted to show, so like if we have an example of this as something you can depend on, which is a component, and it's like it exports this interface that is defined in like this WIT over here. Today, you can use cargo component add. And so I don't know, how much everybody here is familiar with cargo component, but you can have component dependencies, which are actually the default. And in order to use what people tend to use today, you have to use a target flag, which is like how you would say that you want to actually target a world and have a dependency on WIT rather than having a dependency on some component. And so if you do just cargo component add and reference some component that exists in the registry, you'll end up depending on the component here, and the output will, can we view the raw? It basically, we can, have an unlocked import right now. So we actually have language toolchains that like already are producing binaries with unlocked dependencies. The one thing though is that if you look over here, so when we had past demos where we like demonstrated locking unlocked components, we define our instance types, but because language toolchains aren't great at leveraging unlocked depths yet, these instance types are like fairly simple because all the WATs that we're using are handwritten that like a kind of prototype and exemplify how unlocked depths would work. So if you actually use a language toolchain to produce something, you'll end up with a component that exports instances that export an instance. And because of that, like there's been kind of these issues in the WIT-MD that describe how we could have a syntax for nested interfaces. And so basically, this is in the middle of being implemented. And when you have this, then you could have like a feature parity between WIT and the WAT text format, and then basically be able to produce binaries that can take advantage of unlocked depths, and you would be able to have dependencies so that way you can just do cargo component add, and you don't need to have like a WAC step basically, and instead you would just do Semver resolution of different implementations. And so there's that, and then we also have some proposals for WIT unlocked depth syntax too, which would essentially communicate to our language tool chains that this WIT should be used, or that we should have unlocked dependencies in the binary that is spit out based on the dependencies that are specified in the respective languages package file. So yeah, that was a lot of information too. And I kind of figured that some of this stuff probably makes a lot of sense for Birds of a Feather, but I also figured I should communicate what kinds of things might be discussed in Birds of a Feather. So I don't know, I'm happy to answer any questions about it too, but that's kind of a high level overview that was actually also pretty in the weeds. Yeah.
Questions, comments? It's Bailey.
I understand wanting feature parity with what's in the component, like in the binary format. When would I use the WIT textual format with locked depths?
Yeah, so basically you wouldn't, and like tools like Cargo Component today already kind of like synthesize WIT. So the idea should be that you as a developer shouldn't ever be like authoring this WIT yourself, but the like resolve struct that like tools like WIT parser use would be used in the synthesis of a WIT that ends up being used to produce the binary. But yeah, people shouldn't ever actually have to think about unlocked depths on their own very hard.
Why would the tools want to operate with WIT if they're trying to produce a WASM? It seems like they would be operating on a WASM format at that point. And I'm sure Luke can answer. Cool.
So a challenge has been like detangling, untangling all these different related stuff of like registries and some stuff's in file systems. And then there's WIT. There's a bunch of language things and like trying to stage all this stuff so we can like say each tool does like one task. And ideally we want the registry tooling to do registry stuff and not have to understand WIT too well. I want WIT bindgen to be like, all right, I don't know anything about registries. I have all the WIT information. I'm just going to do some binding generation. So we want to like decouple these things. And so one simplifying idea is, what if the output of all the registry stuff is one WIT file that has everything inside of it? And when that one file, you don't like the developer doesn't author it, but we can like check it in and like put it somewhere in the file system. So if I want to see like what's the ground truth, like what ultimately did I get after all the resolution is done? Show me the full gory details in WIT, not in, I don't want to read WAT because that's pretty hard to read, but WIT can be readable when it's, as we add expressivity, can capture all the information. So give me one WIT file that is the result of all the registry stuff and is the input to WIT bindgen. And so now I've staged these things. And that means I also have this nice intermediate point. So like maybe there's different ways of getting WIT and different producer tools can feed into that thing. And then meanwhile, WIT bindgen doesn't have to change. It's just like, give me the one WIT, I'll do my stuff. And so it's really a decoupling of this otherwise very intertwingled tooling problem.
But also at the end of the day too, if you're depending on an implementation and it was implemented in whatever language, you need to be able to import bindings for you. And generally WIT is what is used to make it so that you have something in your source language that you're able to file down your WASM. So I think that there's that too.
That's one of the things I was trying to suss out there is, now that Alex has added support to be able to pass in a WASM and a WIT BindGen, it's like, which one would when would I use one or the other? Go ahead, Luke.
The use case we were just actually talking to Lan about was sometimes you want to see what's the ground truth. And today people refer to WAT, but that's like pretty rough to be like, oh, go read the assembly. So what we're talking about is there's some expressivity gaps in WIT where you just can't see the full gory details, but we know what they would look like to add that. And it would allow you to specify, all right, this is precisely who gets what version. This is when you're using the same resource type. This is when you have a different resource type. All that sort of the stuff when it goes wrong and you want to debug it. If we add that expressivity to WIT, then this one WIT file can be the human readable kind of like, this is what happened after it's all done file. So it serves a kind of developer oriented purpose that's better than WAT or yeah.
Have any other questions? I also imagine that some of us will spend some time talking about this later while we're.
About this since it worked further down the line too.
Cool. Well, I think that's most of what we've got for the packaging updates.
Anything else before we finish? Okay, thank you very much.